Force, mass and acceleration. Here we have an air track with a truck. On top of the truck is a card of known length. This will pass through a light gate here and a light gate here. The light gates will be connected to a computer to calculate the acceleration between this point and this point. Attached to the truck is a thin cord with a mass at this point to produce a resultant force to accelerate the truck. First we'll keep the mass of the truck constant and increase the load on the pulley here to increase the accelerating force. If we plot a graph of the acceleration against force with the truck of a constant mass, we get a straight line through the origin. This shows us that the acceleration is directly proportional to the accelerating force. We can write that as A alpha F, where the Greek letter alpha means directly proportional to. As we double the force, we double the acceleration. We can change this into an equation by adding a constant, and we get that the force is equal to a constant times the acceleration. If we now keep the accelerating force constant, but change the mass of the trolley, and plot a graph of acceleration against 1 over the mass, again we get a straight line through the origin. This shows us that acceleration is inversely proportional to mass. For a constant force, if we double the mass, the acceleration halves. We can write this as A alpha 1 over m, or the force is equal to a constant over the mass. We can combine these two to give the force is equal to the mass times the acceleration. When the force is in newtons, the mass in kilograms, and the acceleration in meters per second squared, the constant is just 1.